Hey class, in this video I am going to be doing a lecture on digital images. There's not going to be any demo component to this, so you don't need to be using Photoshop or following along. I'm just going to go over some of the basic concepts that are going to help us understand what we're working with when we start using Photoshop in our demo. I'm going to mostly be looking at some slides in Photoshop, but just to kind of get us situated, here we are on Brightspace. Make myself smaller. We are in our first topic, which is image, and we're going to be talking about how to make digital images. I'll go over some of this stuff in later videos. But there's some resources here. There's some links to Adobe tutorials. These links do work, even though OpenLab seems to think they don't. Still working on fixing that. A couple examples of some of the types of images that we're going to be making. We're going to be making 3 different images, a couple of basic starter images, and then a final project. And then here's some information about how to submit the final project for this section. I'm not going to go over this right now, but we'll go over that in a later video. For now, we're just going to kind of talk about the basics of digital images. So I'm going to hop over to Photoshop where I have some slides, and we'll just kind of go through. So we're talking about digital images, just to kind of introduce what that means. We are going to look at, in our first unit, how to sort of create images, how to change the format of images for different platforms, how to edit images, and the different software that we use to do those things. So you've probably, seen lots of images on your phone today, on your computer, in various contexts. And making images look good and fit the appropriate context and things like that, it's helpful to understand some of the technical aspects to how images are made. So we're going to talk about how we kind of make an image on the computer, and some of the sort of technical components that go into making an image and saving an image on the computer. And we'll talk about a couple other things related to using images in a digital context. So I'm in Photoshop right now. I just made some slides in here. You don't need to be using Photoshop, but I'm just going to go to the next slide. So in this unit, we're going to be working with Photoshop, and Photoshop is good for editing photos. So it's called Photoshop for a reason. It's really originally designed to take a photo taken with a real camera, and then edit it to change the color or add things or add graphic design components on top of it. And so photographic images we typically display on the computer using pixels. And so pixels is one way of rendering an image. A pixel is basically just a square that's usually represented by a light on your monitor that combines color values. And so we can see, on the left here, we have this nice picture of a lizard. And if we have enough pixels kind of close together, we can kind of recreate an image that looks like a real thing. We can't see the sort of parts of it that are digital. When we zoom in, and here's a zoomed in look, but I can also just zoom in on my computer. As we zoom into the details of this image, eventually we see the individual squares or pixels that come together to make the detail of the image. So before we had digital images, when we had analog cameras, when you made an image of something with an analog camera, you didn't have that zoom in to the pixels quality. No matter how far you zoom in, you would just see more and more and more detail. So that's one thing that makes digital images different from analog images. The way that our computers are designed and the way that we save information, we need to represent images as little sort of squares of color. So that's what a pixel is. So when we create a pixel, what we're doing is we're combining a certain amount of red, green, and blue colors. And so each pixel has a certain amount of red, green, and blue, and depending on how much of those values we use, you're going to get a different color. So you can see some different examples here. This circle over here on the right is black, and that means it has 0 red, 0 green, and 0 blue. So with 0 color, we get the absence of color, we get black. Down here, this white circle has full red, full green, and full blue. So if we add as much color as we can on each channel, we get white. Each one of these colors represents a pure red, green, and blue. So over here, the value here is 255. On the next slide, I'll explain where that comes from, but that means as much red as possible. And then 0 green, 0 blue. And then we have the same thing here, 0 red, 0 green, and 255 blue gives us this blue dot. Down here, 0 red, 255 green, 0 blue gives us this green dot. Since we're in Photoshop, we can take a look at a color picker. It's actually hard to see because my screen is a little small, but let's go to the window and go to color, and I'll just pull this out. So this is what a color picker looks like, and if we make this a little bit bigger, we can see those values here. So you can see R, G, and B. There's a few different ways of talking about color, but this is where we're going to start. So if I go here, if I do 0R and 0G and 0B, we get that black color. And then if we add 255 to R, that's the most red you can get. You can see this little slider here. So if we have 0R and 255R, same thing with green. If we add in that green, we get this combination of red and green that ends up being yellow. And then if we add in our blue, we get that white color. So we'll work more with color in our Photoshop lesson, but we can see how those values fit together. So why 255? So that has to do with the way that computers store information. Let me hide myself for just a second. Okay, so the way that we save data on a computer is using something called bits. Bit stands for binary digit. This is sort of the smallest form of data that can be stored on a computer. And what a bit is, it's just a 0 or a 1. It's an on and off. It's like a light switch. If you think of a light switch, it's either on or off. If it's on, the light's on. If it's off, the light is off. Computers have these little tiny things called transistors that save these states. And that's how computer memory is created, by millions and millions and millions of these little tiny on-off switches that use electricity to be set on or off. So a bit is the smallest form of information. And then we add that together using a format called binary. Binary is a way of counting. So instead of counting 1, 2, 3, 4, 5, we count using zeros to represent different values. So a byte is 8 values, and each one of those values is either a 0 or a 1. Let me get my little annotation tool here. So in our byte, the first value can either be a 0 or a 1. And that is just going to be 1. So if it's a 0, we add 0. If it's a 1, we add 1. The next one is 2. And so if there's a 0 here, then we add 2. If there's a 0 here, we add 0. Then it goes 4, and it keeps going up to 8, 16, 32, 64. Let me get a smaller. I'm running out of space here. 64. And the last one is 128. I'm drawing with my mouse, which is why that looks kind of bad. Normally, I have a little pen, but I left that at the office. Anyway, this is what you end up with. So if you add these numbers together, you can get any number between 0 and 255. So this is sort of an efficient way to store values from 0 to 255 on the computer, only using 8 little pieces of data. And so that's why we use 255 as sort of the basis for a lot of numbers, including the amount of color that we add, just because it's a convenient way to save data on a computer. So you can see if we have all zeros, we get the value 0. If we have all ones, that ends up being the value 255. If we have a different number of zeros and ones, we get a different value. So to get 100, so we have 0 for 1, 0 for 2, then we have 1 for 4. Then we have 0 for 8, we have 0 for 16, we have 1 for 32, and we have 1 for 64. And then we have 0 for 128. So if we add those together, 64 plus 32 gives you 96. And then if you add 4, you get 100. And then we don't add these, so that all adds up to 100. So it's just a way of saving information that we use for digital computers. Okay, so that's bits and bytes. So how does this actually work when we're saving data? So this is related to what's called sampling and quantization. So this will make a little bit more sense when we look at it in terms of audio, but anytime we have something that's analog, it has something called a signal. And the signal is a stream of information. With a photograph, it's a bunch of different colors with different contrasts. And when we digitize something, we take that analog signal and we do what's called sampling. Since we can't save infinite data digitally, what we do is we pick out a few samples along the line, and if we do enough of it, we won't really be able to tell the difference between the original photograph and the digital photograph. And so we take our signal and we just take little samples along the way, but we take enough of them that we get enough data that we can kind of trick ourselves into seeing the image. So just like with our lizard image in the first slide, if we look at it from here, it looks like a lizard, but as we zoom in, we start to realize that some of that data is actually missing, and what we really have is just squares that kind of make up a version of that image. So that's called sampling. The other aspect of creating an image is called quantization. That's how much information do we save per sample. So with one sample from our photograph, one pixel, one individual color, we save a byte for red, a byte for green, a byte for blue, and then we also save a byte for what's called alpha or transparency, how see-through it is. So for each one of our dots in our lizard, we have 4 bytes to save the red, green, blue, and transparent values for that image. And when we add all those together, you can see we have a whole big grid of pixels that makes our image. So the image size is how many pixels wide and how many pixels tall. When we talk about wide, we use the word columns. So the image might be 200 pixels. The lizard image is probably more than that. 200 pixels wide, and it might be 200 pixels high. Again, the lizard image is probably larger than both of those values, but just as an example. So every image is made up of a number of pixels in the width and the pixels in the height, and the total pixels in the image is those two numbers multiplied by each other, which is a much, much larger number. So images have tons and tons of data, and that's another thing that we'll talk about when we do our demo with Photoshop with saving files. So image resolution, it refers to the number of pixels per inch. So when we take an image and then we scan it into a computer, we usually set how many dots per inch we want, and that determines the outcome of the image. So obviously the more information we save, the more space it takes up on the computer, and the higher resolution or the better quality the image is going to be. If we want a smaller file size that doesn't take as much space on the computer, that's faster to send across the internet or text or something like that, we can lower the quality of the image and also lower the file size. So to put that in terms of something you may be familiar with, if you ever had the original iPhone, which came out in 2007, that had a pretty small screen. The resolution was 320 pixels by 480 pixels, which works out to 163 pixels per inch. So that looks pretty good back in 2007. But more recently, the iPhone 14, which at this point is actually a couple generations ago, their screen was 1170 or 1170 pixels by 25 132 pixels, so it's 460 pixels per inch, almost 3 times as high resolution. So the quality of an image that you can see on your phone today is much higher than it was when the iPhone first came out, almost 20 years ago. So here's an example of that. We see the size of the iPhone 1 versus the iPhone 14 over here. When it comes to how we represent images on a computer, there are 2 different types of graphics. There are raster graphics, which is most of what we work with in Photoshop, and there's also vector graphics. We aren't going to do a lot with vector graphics in this class, but you may spend a lot more time with that if you take MMA 100 or the Introduction to Digital Design and other digital design classes. The main difference that we want to talk about between raster and vector is raster basically is the pixel grid that we've been looking at in previous examples. Oh, I forgot to bring myself back. There I am. So with a raster, we just have lots of pixels, and we just kind of make the image out of those pixels. So in this example, you can see this raster right here. I'm going to open this up. And this is a rasterized piece of text. So if I zoom into here, as I get closer and closer, you're going to eventually see pixels. And you can see the way that Photoshop makes it look like this is a smooth line is by shading the edges a little bit. So we have, instead of pure black here, we have lighter versions of gray. And so when we zoom out, that makes this kind of look like a smooth line, but it's not a smooth line. It's a bunch of pixels. That's opposed to vector. So if I zoom into this vector, notice these blue lines. So don't worry about the black fill, because based on the size of the image, those are going to be rendered pixels. But the vector graphic actually just uses points, and it uses points on the page, to determine where to draw. So you can see as I zoom closer and closer in, this blue line has infinite resolution. The blue line never gets pixelated, even though the fill gets pixelated. So the blue line is a vector, and the vector tells the program where to draw the fill. And the vector has infinite resolution. So you can see the dots that form the vector. These, instead of pixels, are just dots on the screen, and the program fills in the information in between the dots. So that's what vector graphics looks like. We're not going to be using vector graphics in this class, so we don't have to worry about it too much, but just wanted to give an example there. So in a raster image, it's a grid of pixels. Resizing the image changes the quality. So if you take a small grid of pixels and you blow it up, it's going to look more pixelated and more blurry. If you take a really high resolution image and shrink it, you're going to lose quality. We usually use raster for photographs. We do that because there's a lot of detail, and so we need to save the detail in an efficient manner, which is through pixels. Photoshop is usually used to edit raster graphics. We can create vector graphics, but we usually, when we export it, it turns into raster. And we can save in a lot of different image formats. We'll go over this more in another demo, but we'll go over creating JPEGs, PNGs, GIFs, and PSDs. With vector graphics, there are coordinates rather than color data. Resizing does not change the image quality, so a vector graphic you can zoom in or zoom out as much as you want. We typically use these for simpler designs like logos and illustration. Adobe Illustrator is the main editor you use for vector graphics, and it's a little more limited in terms of the image format because most digital devices use raster graphics. So you can use Adobe Illustrator, you can use SVG, which is a format to export vector graphics, which is supported by a lot of different devices to make vector graphics. So when we do raster graphics, we usually use raster for images, like our lizard image here. If we are doing something with vector graphics, we might do something more like the Apple logo, where we want really smooth simple lines. You can understand that that makes sense because in our raster image, we've got lots and lots of little colors. And so saving each one of those as a separate vector would take up a lot of space on the computer. Whereas a simple Apple logo, that actually becomes more efficient since we just have a few points that we have to point out for our vector graphic. We don't have to save all of the pixel data. So when we export files, we're going to be editing files in Photoshop and then exporting them as JPEGs and PNGs and GIFs. I'm going to go over this a little bit more in the next demo. But that's something that we're going to talk a lot about in this class, where we have edit files, which are the files that we use to create media, and then we have exported files, which are the files that we use to share media with other people. Copyright is another big thing that we're going to be talking about throughout the class. We'll talk a lot about this actually more next week when we make a image composite, but it's an important topic that we'll look at in every unit in this semester. So when we want to use images, we can take images on our own and we can do whatever we want with those. So if you take a photo on your iPhone, or you snap a photo and scan it onto the computer, or you make an image in another way like that, you can do whatever you want with it. If you use images that were created by other people that are available on the internet, there are rules about what you're allowed to use and what you're not allowed to use. We are going to be talking about that in terms of using what's called Creative Commons licensing for images. Creative Commons is a organization that creates different licenses, which are legal ways to use things created by other people, and legal ways to distribute things that you want other people to be able to use. So we'll talk a lot more about this next week when we start to use some source images. When we cite images that we use, we're going to use citations. Here's a couple examples of how you might cite a work. This is a lot like citing an article that you might reference in a paper, but we're going to be citing media that we use in our projects. So again, I'll cover this a bit more in depth next week when we use some images. For now, that's all I've got for our intro to digital imaging. Let me know if you have any questions about anything that I have covered in this lecture. In our next demo, in the next video that you'll see after this one, we're going to start actually using Photoshop. So we're just going to have a quick little intro. I'll go over how to use some of the basic tools in Photoshop and how to use layers, and we'll kind of get started with that. So I'll see you guys in the next video.